Hello and welcome. Are you feeling a little overwhelmed by all the formulas in IGCSE physics? Yeah, you're not alone. But you've come to the right place. In this explainer, we're going to build your complete toolkit with every single formula and calculation tip you will ever need. We're going to turn this tricky topic into something you can totally master.
Look, physics calculations can feel like a massive hurdle, but they really don't have to be. Imagine having every single equation, plus all the common exam tricks and tips, all laid out for you in one spot. Well, that is exactly what we are about to do together. So let's get into it. So here's our game plan. We're going to move step by step right through the IGCSE syllabus. We'll kick things off with mechanics, work our way through energy, waves, and electricity, and go all the way up to astrophysics. By the end, you'll have a super clear, organized set of tools for your exam. All right, let's dive right in with Section 1, Mechanics. This stuff is really the bedrock of physics, It covers everything from a car speeding up to the forces that keep planets zipping around in orbit. Let's make sure we build a really strong foundation here. Okay, let's start with the absolute basics. And listen, pay super close attention to the units. They are your secret weapon, I promise. Speed, that's easy, just distance over time. For acceleration, we're looking at the change in velocity over time. A quick tip, if something starts from rest, its initial velocity, that's u, is just 0. It makes the math way simpler. Weight is just the force of gravity on an object, and density tells us how much stuff is packed into a space. Seriously, nail these units and you're already halfway to the right answer. So how does this actually show up in an exam? Well, usually in graphs. On any speed-time graph, the steepness of the line, what we call the gradient, that's your acceleration. And the area underneath that graph, that gives you the total distance the object traveled. And here's a classic exam trick. You might get a question about heat capacity, but you first have to figure out the object's mass using its density and volume. It's a two-step problem in disguise, so watch out for it. Now let's talk about the forces that actually cause all this motion. Hooke's law, that's all about how springs stretch. Newton's second law, F equals ma, is probably the most famous equation in all of physics. It's the key that connects the force on an object to its mass and acceleration. For moments, I want you to think about using a wrench. It's a turning force, and the absolute key here is that the distance has to be measured at a perfect right angle from the pivot point. Finally, momentum is basically mass in motion. It's just mass times velocity. Okay, listen up, because this is probably the single biggest mistake students make with momentum. Momentum is a vector, which means direction matters a lot. So if we say the initial motion is positive, then when that ball bounces back and goes the other way, its velocity becomes negative. You have to put that minus sign in when you calculate the change in momentum. If you forget, you will get the answer wrong. It's a classic exam trap, so don't fall for it. Okay, toolkit updated. Let's move on to our next section, energy, work, and power. These concepts are all about how energy gets transferred and used. These four formulas are all deeply connected. Power tells you how quickly energy is being used. The two main types of energy you'll see are kinetic energy, for anything that's moving, and gravitational potential energy, for things that are up high. And then there's efficiency, which just measures how well a device converts energy. Useful output is the energy doing the job you want, like the light from a bulb, while total input is all the electricity it uses up. Just remember, useful out divided by total in times 100. Now for pressure. It is so important to know which formula to use. For pressure from a solid object, like a box on the floor, it's just force divided by area. Simple. But for pressure inside a liquid, the formula is totally different. It depends on the height or depth of the liquid, its density, and gravity. So the main takeaway is, always check if the question is about a solid or a liquid before you even think about picking an equation. All right, we're making great progress. We're halfway there. Now for Section 3, where we'll cover all the essential formulas for heat and waves, and that includes light and sound too. This slide hits two really important areas. First up, for waves, the big one is wave speed equals frequency times wavelength. That funny-looking symbol, lambda, just means wavelength, and frequency itself is just 1 divided by the time period. Then, over in thermal physics, we have Boyle's law, which describes how pressure and volume are linked for a gas. And to calculate heat energy, we use E equals mc delta theta, where C is the specific heat capacity and delta theta is just a fancy way of saying the change in temperature. Here are 3 awesome tips that are going to save you so many marks. First, for refractive index, you've got 2 formulas. Just pick the one that matches the numbers they give you in the question. Second, examiners absolutely love to trick you with angles. You must always measure from the normal, that imaginary line that's perpendicular to the surface, never from the surface itself. And finally, for echo questions, please remember the sound makes a round trip. It goes there and back. So the distance you calculate is double the real distance. Don't forget to divide by 2 at the end. Let's keep the momentum going and tackle what many students find the trickiest topic of all, electricity and magnetism. But don't you worry, once you get these formulas locked in your head, the calculations become a whole lot easier. This slide right here holds the key to pretty much all circuit calculations. It all starts with the king of them all, Ohm's law, V equals I times R. This is the fundamental relationship. From this one law, we can figure out all the formulas for electrical power. See how they all use V, I, and R? And since energy is just power used over a certain time, we can then figure out the total energy used. It all comes back to V equals IR. So what happens when you have more than one resistor? Well, the rules are simple but different. For resistors in series, one after the other, you just add them up. Easy. But for resistors in parallel branches, you have to use that inverse formula. So here's the crucial part. After you calculate 1 over R total for a parallel circuit, you have to remember to flip your final answer to find the actual total resistance. So many people forget that last step. When it comes to magnetism, the main calculation you're going to do involves transformers. And honestly, the formula is a piece of cake. It's just a simple ratio. The voltage ratio between the primary and secondary coils is exactly the same as the ratio of the number of turns in those coils. If you know 3 of these values, you can always find the 4th. Okay, time to zoom in to the atomic world with Section 5, Nuclear Physics. Now, this topic has fewer formulas, but it requires a very specific calculation method that you need to follow every single time. This slide breaks down the 4-step process for every single half-life calculation. You have to follow this every time, okay? Step 1. Always subtract the background radiation first. Step 2. Then you have the corrected count for each half-life that passes. Step 3. Calculate the total time. And step 4, and this is the one everyone forgets. If the question asks for the final reading on the detector, you have to remember to add that background radiation back on at the end. Steps 1 and 4 are so easily missed, so don't let that be you. And for our final section, we are going big, like really big. Section 6 covers the formulas you'll need for astrophysics, the study of the entire universe. And here we are, the final 2 formulas for your toolkit. To find the speed of something in orbit, you're basically just using speed equals distance over time. The distance is just the circumference of the circle, which is 2 pi r, and the time is the orbital period. Then, for the whole universe, on a grand scale, we use Hubble's law. It just tells us that the speed a galaxy is moving away from us is proportional to how far away it is. And there you have it. That's your complete toolkit for IGCSE physics calculations. From the motion of a ball to the expansion of the universe, you now have every single formula you need. The key from here is practice. Use this toolkit, work through those past paper questions, and I guarantee you will be ready to confidently take on any calculation they throw at you. Fundu Tutor is a personalized learning platform that helps students succeed in Cambridge, IB, and other international curriculums with expert mentorship, structured learning support, and engaging resources.